All right, here we're on chapter 7, and this is section 7.1 on Introduction to Rational Expressions. All right, so our objectives for this section are evaluating rational expressions, simplifying rational expressions, and then solving applications involving rational expressions. So let's look at evaluating rational expressions first. So rational expressions can be written as a quotient, basically a fraction of two polynomials. Some examples are 5 over x, that's kind of a really simple one. Then we have x squared over 3x minus 4, or even 4x squared plus 6x minus 1 over 4x cubed minus 8. So here we have a trinomial over a binomial. Here we just have a monomial over a binomial, and these are just two monomials. Now, a rational expression can be written as p divided by q, where p and q are polynomials, and a rational expression is defined whenever this denominator is not equal to 0. So if the denominator is equal to 0, then it's not defined. All right, so let's evaluate some here. So if possible, supposed to evaluate each expression for the given value. So what all we're doing is we're plugging in this 3 here for x. So when we do that, plugging in 3 here, we should get 1 over 6. So we're just plugging in 3, we get 1 over 6. Now, here we're plugging in 4. Okay, so when we plug in 4, what do we get? Well, we're going to have 3 times the 4 is going to be 12, minus that's going to be 8, and on the numerator, it's going to be 4 squared, it's going to be 16. So 16 divided by 8 is going to give us 2. Okay, so that's how that one works. Next one, we plug in a negative 5. So 4 minus a minus 5 is going to be 4 plus 5, so that's going to be 9. And we have a minus 5 minus 4 is going to be minus 9, so that gives us a minus 1. So here we just have to remember there's a positive here, negative here, so we still have a negative in our value. All right, so let's look at some others. So it says find all values of the variable for which each expression is undefined. Now remember, being undefined means 0 down here. Well, this one, if we set this equal to 0, that means x is going to be 0 is the only value it's going to be undefined at. And so we look at that, and that's what we get. Now here we set w minus 4 equal to 0, and if we do that, we say add it to the other side, so w equals 4 is going to be the value where it's undefined at. And here we have to remember the property of square roots. So we take the 4 across, and we get w squared equals 4. And when we take the square root of the w, we have to take plus or minus the square root of 4. So we're going to get plus or minus 2 on this one. So that's a key thing here is we have to remember when you take the square root, you get plus or minus the other value. All right, so now here we're supposed to simplify each fraction by applying the basic principle of fractions. And so with these, what we want to do is we want to reduce as much as possible. So like in the first one, 3 will go into 9 3 times, 3 will go into 15 5 times. So we should get 3/5 as our GCF that we can cancel, or our final answer after we cancel out the 3. And so if we look here, 3/5 is going to be our answer because we're going to cancel out that 3. Now, what about this one? We're going to divide out a 4, so we'll get a 5 over 7, and that's what we get here. 5 over 7 is left out because the 4 over 4 cancels, and we get 5 over 7. Now here it looks like we're going to have can't talk here. 45 can go into both of them. So 45 goes into here, 45 goes into here, cancels, and we end up with 1/3. So that one is one that you have to think about. And if you don't see it right away, 45, what we could have done here on this bottom one is if I can find there it is. If I find this, I can say, well, I know if 5 goes in here 9, and if 5 goes in here, well, it's going to go in here 20, let's see, 2, and then we have 35, and that's 7. And write it down. Now 9 will go in here once, 9 will go in here 3, and we still get the 1/3. It just took us an extra step. And we could have even done it by threes. We could have, okay, well, they both can be divisible by 3, go down by threes until we get done, and that's how that would work there. Okay, and we'd have to do 1/5 at least, but that's going to be something you can do there. All right, so let's stop there and we'll come back for some more.